So today we're going to review compound interest, and later in the week you're going to see what we do today actually leads to the next topic. We're sort of going to discover it that way. But for the starter, the n value here, number of times compounded, is what n stands for, right? So annually, we know that that's 1 time per year. Semi-annually, that would be 2 times per year. Quarterly, monthly is how many times per year? Bi-weekly is every other week the whole year. Weekly is once a week, which is 52 times a year. Daily is every day, so 365 times per year. Hourly would be 365 times 24 hours, right? Every minute. And every second. 31,536,000 times per year. Okay, so that's what the n values are for all those magic words that are basically the frequency of how often you would be compounding the interest. So now here's what we'll do. We're going to open up the compound interest calculator that we did last week in Google Sheets. We're going to copy and paste that calculator onto the same sheet, and I'll show you what I mean by that. And then we're going to determine the balance for all 10 of these n values up here. But we're going to keep the deposit of $2,350, the interest rate of 3.1%, and the length of time of 5 years. We're going to keep all of this the same. The only thing we're going to change, we're going to try to do this calculation once a year, twice a year, 4 times a year. We're going to compound it more and more frequently, which should result in more and more interest, more and more money, and we're going to discover what happens when we keep increasing the amount of times we compound all the way up through seconds, every second. And something interesting will happen. So now we're going to create 10 different calculators, and we'll put those values in, and we'll do that together. We're going to open up your compound interest calculator from earlier in the week, or from last week. And what I did here on line 25, I put a little black bar, so I basically just, you color it whatever color you want, and I centered, I think I merged it too, I merged all of those cells, and then centered the word starter there. Just to give us a little section to do this in, so go ahead and do that. Then, I'm going to borrow one of these compound interest calculators. I'm going to copy that whole chunk right there. I'm going to paste it right here. But I have to then go back and delete the information in there, but not this cell. Do not delete what is in B32 because that's our important formula. We don't want to type that again. Okay, so, but these are blank. Because what we're going to do is go back and look at this information that we wanted to use, 2,350 at 3.1% for 5 years. So $2,350 at 3.1%, which is 0.031. I'm going to leave this blank for a minute because that's going to be the n value that we're going to change every time. But it was always going to be 5 years right here. 5 years, 3.1%, and 2,350. The only thing we're going to change 10 different times is this right here. So now that I have, this is reminding me that that's the one I'm going to change. So now I'm going to make 10 copies of this just to save myself time. So I'm going to copy A27 down to B32. I'm going to paste a 10th one So I have 10 of them there now, because there are 10 N values up here. So see, I've already started changing the headings. I'm going to go annually, semi-annually, and I'll change this one to quarterly, monthly, and then bi-weekly, followed by weekly, followed by every day, and then every hour, and then every minute, and then every second. So that's just the same words that we used here, and now we're going to use these numbers for the N value. So the N for annual is 1, semi-annually 2, quarterly 4, and so on. So go ahead and put these in now. Annually is 1. Look at that, $2,737.54. Okay, not bad. Semi-annually is 2. Same amount of money, same rate, same time. Oh, I made even more money, $2,740.74. That looked like it went up a few bucks. So obviously, the more I compound, the more money I'm going to get. Quarterly is 4. Yep, even more money, $2,742.36. So this is just going to skyrocket, I guess, right? So monthly is 12. Did this go up? Yeah, it went up a little bit from 2742 to 2743.45. So monthly seemed to increase. Bi-weekly is 26 times per year, 2743.74. So something interesting is happening here. Yes, it's still going up every time. Doesn't seem to go up as much as it did that first time, but let's see what happens. Let's keep going. Weekly is 52 times per year. Yeah, interesting. Still stuck at 27.43, but it went up to 87 cents. Daily, well, this is a lot more often, right? 365 times. This one should be way higher. Let's see. 27.43.98 went up, but even by a smaller amount. See how it's 27.43 and only the pennies went up, even with 365 times. But surely 8,760 hours per year should be enough to make it go up even more. Well, looks like it went up 2 cents from 27.43.98 to 27.44 even. How many minutes are there? 525,600 minutes in a year. Still 27.44 even. Looks like it didn't go up at all. And seconds, 31,536,000 seconds. Still 27.44. So it looked like now all of a sudden it's not moving, but actually it is. If you look in this cell here and I move the decimal point, see how money always rounds off to the nearest hundredth because that's how money works, but see how it actually was going up? 9955, 9962, 9962, and if I went even further on that one, it's to the 10,000th of a penny. It's going up a little bit. So it seems to have leveled off, I guess you could say. No matter how frequently I compound, right? Once a year, once a week, once a day, once every second, you still seem to just kind of max out at a certain amount of money. Over to the side here like I did and recreate this mini little chart. Basically just took the N values once a year, twice a year, 4 times a year, 12 times a year that we typed in here, and then I put the balance in the account. I made like a little chart. So go ahead and type that in. Pause the video and go ahead and make this just over on the side here. And then, once you've got it typed in, let's highlight that data, like that whole chunk, the one right down to the final 27.44. We're going to go up here to Insert, and we're going to insert a chart. And it's going to look really goofy right now, but stay with me, we're going to make it look cool. Comes up probably like this, but even if it doesn't, we're going to change column chart to this line chart. In fact, I'll pick the second one. We'll make a smooth line chart. And it looks really awkward right now. I'm going to click on these numbers on the left, your y-axis numbers. I'm going to go over here where it says min and max. And I'm going to go from 2736 up to 2745, which is basically a little bit lower than the lowest number and a little bit higher than the most money. 2736 and 2745. Then I'm going to click on the bottom axis, the x-axis, which is always time. Okay, and we're going to change that minimum value. We'll go from 0 up to, and the last one here was 31,536,000 for seconds. So I'll make that be my maximum. And the last thing we're going to do is treat labels as text. So click on this box right here. And this should be what you have. And you didn't need to do that, but if you wanted to make it look fancier with colors and contrast, you can. But look what happened there. The more frequently I compounded. Zoom in here. Once a year, twice a year got me quite a bit more money relative to the rest. 4 times a year, 12 times a year, 26 times a year. But then look what happens. It sort of seems to level off. And we talked about it really didn't level off, because if you open up that decimal and go further out past pennies, you see that it did go up a little bit, but it got stuck at 27.44. As far as money goes, it sort of reached what we call a limit. So all of us have different math courses in our history. You know, some of us have taken Algebra 2, some of us have taken pre-calc, some of us are in calculus, and some haven't. But some of you know this word, so I'm going to introduce it and remind you that this is a real-life application of it. Our graph sort of looked like that. And money was on the left, on the y-axis. Time is usually the x-axis. What happened here is this line right here, which doesn't really exist. But that was our upper limit. You can see right here, theoretically, those will never meet. This pink will keep getting higher and infinitely closer to that dotted line, but it will never actually hit it. It inches closer and closer and closer to it, but never actually hits it. So those of you that have learned this word in math and learn it later on in math, you now have a financial application for what a limit really is. And you might remember, if you took certain courses, that this dotted line that it almost meets is called an asymptote. It's fun to say, asymptote. And it reaches a limit. So the purpose of going over all that was to show you that if you had the same amount of money, the same interest rate, and the same amount of time, 5 years, but you compounded it only once a year, twice a year, 4 times a year, all the way up to 31 million times a year, eventually you wouldn't continue to grow the balance. It would level off no matter what. So no matter how fast or how frequently you compound money, you're going to hit this limit. And that's what we're going to talk about on Thursday. This is going to lead us into a simpler formula that accounts for the fastest you could ever compound money. And we'll come back to that later in the week.